Hi, I'm Jacob Schultz, and this is the story of my physics project. Originally, I had several different ideas for what I wanted to do. At one point, I floated the idea of coding a simulator of special relativity. However, a lot of my final projects have been in the form of programs, and I wanted to do something different. I decided to make a physical device to measure temperature, humidity, and soil moisture. This would allow me to use an Arduino, which I had never used before, and get me out into nature for a little while. The plan was to get sensors to measure the three properties, then use Wi-Fi to send the data to the cloud, where I could do analysis on it. I came across this Arduino project, which provided me with the soil moisture side of the project, and another project that provided me with all three. I then bought the necessary parts from SparkFun and the Arduino store. These were an Arduino Uno R4 Wi-Fi, a SparkFun soil moisture sensor with screw terminals, a DHT20 humidity and temperature sensor, a breadboard, a USB-C to USB cable, and some jumper wires. Then it was time to begin putting it together. The SparkFun sensor works by measuring the resistance between its two terminals, and since water is a better conductor than soil, the less resistance there is, the more moisture there must be. It had a simple guide on setting it up, complete with code, which works quite well after I connected it to the Arduino. I connected ground to ground, analog out to analog in, and power to a digital pin, so I could power it only when I needed to use it to avoid corrosion of the terminals in the soil. Right now, it's just sort of, not doing anything, and as you can see, you've got a soil moisture of about 14, 15. But if I put my body here, my hand here, you can see that the moisture has gone up to about 851 because that is the moisture inside me. The DHT20 was more complicated. It used a special protocol called I2C that was quite detailed. Thankfully, there was a GitHub repository that provided me with specialized functions for this device. I connected the DHT20 sensor to the Arduino through the breadboard. This wire is for power, this wire is for ground, this wire is for data, and this one acts as a clock for synchronization. This is where I hit my first major bug. The sensor would always return read timeout and 0.0 for temperature and humidity, no matter what. And Vancouver summers are never that cold. I confirmed that the DHT20 was indeed connected, but it still only returned 0.0. I couldn't decipher it, and so I sought the help of the Arduino forum. The user Vanderdecken told me that I shouldn't connect the DHT20 directly to the power and ground of the Arduino, but instead wire them through the plus and minus lines of the breadboard. I followed his advice, and it worked. The DHT20 was giving me good readings. I'm sure that's the last you'll hear about this thing's technical problems. Now it was time to connect it to the internet. I originally planned on using a Jupyter notebook, but I came across an article that was a how-to on basically the same thing I was doing, but using Google Sheets instead, which would be a lot easier. It used Wi-Fi to send an HTTP GET request to the URL of a Google script that would append the data to a Google Sheets spreadsheet. The thing is, this used an ESP32 microcontroller as well, and I didn't have it, but it was only used for providing Wi-Fi support, which my Arduino can do already. However, modifying the code to work with the Arduino instead of the ESP32 was rather frustrating, and there were many bugs that came with it. Firstly, the code specified a time variable, which I was planning on having anyway, so I installed another library for connecting to the network time protocol, which is a whole thing, and then I had to convert between different time formats, which took me several tries to get right. Eventually though, the Google script worked, but the Arduino was having problems remotely running it. After numerous small bugs being fixed, I came across the root issue. I was using an HTTP library, but script.google.com only ran on HTTPS. I was once again stuck, as I didn't know how to make HTTPS requests with the built-in Wi-Fi. Thus, I once again headed to the Arduino forums, where the user JML suggested that there was an example of an SSL web client in the docs, which turned out to be the solution. The most embarrassing part is that I'd seen this example before, but glossed over it. It's always in the last place you look, I suppose. And so, after all that, I finally got the Arduino writing to the Google Sheets. Sometimes it would try, but the server just wouldn't respond. I eventually solved this by just making the Arduino print the output of its request. My hypothesis is that the Arduino is sending messages too quickly, and the printing makes it slow down. I honestly don't know. However, there were more important matters to attend to, and that was the matter of deployment. I plugged the Arduino into a battery and placed the device outside. Then my family and I tried out several different coverings for the Arduino. I wanted it to be protected from rain, but able to make accurate readings of the air. We tried several designs before settling on this table-like design with 3 legs. Then I left it out in the garden for a while. Unfortunately, this is when one last bug reared its head. While I got plenty of data on the soil's moisture, the temperature and humidity sensor had the same values the entire time, even when I did things that would change them, like blow on the sensor. Apparently, this value freezing is a known bug. The recommended fix for this is to reset the DHT20 after every reading. I inserted some code that would do this, and it worked for a little while, but the values eventually started freezing again. I hadn't noticed the bug before because I had ran the code over short periods of time where I didn't expect the values to change. This is unfortunate because it means for the DHT20 I only have a few real data points. But here are some graphs of the data anyway. This is the soil moisture over time, and here's a view with the y-axis focused on the data points. There are two different sections here from different places I put the soil moisture sensor. Here is a histogram of the values, where you can clearly see the difference in moisture. Finally, here's a graph of the temperature and humidity. You can see that whereas the moisture sensor had variations, in the temperature and humidity there are long stretches without changes. Here's a close-up of when I attempted to fix the issue. Notice the few real values before long stretches of freezing. This device has several advantages and disadvantages. The main advantage of the device is that it sends data to a Google Sheet where it can be analyzed later. This means you can run analysis on the data later, make correlations, plot variables, and share it with others. It also means you don't need a computer hooked up to it, making it portable and able to be placed in an actual garden. Another advantage is its use of multiple sensors. It is designed to take readings of temperature and humidity as well, so you can see and test how all three values correlate. The main disadvantage, of course, is that one of the sensors doesn't work properly. This is, again, extremely unfortunate, and I didn't have time to fix it. In the future, I will even make my own code instead of using the library, or consider using a more expensive and presumably higher quality temperature and moisture sensor. Another disadvantage is that connections to the breadboard are not secure. Thus, sometimes the DHT20 doesn't connect at the beginning, so you need to disconnect and reconnect it. I would also like to incorporate more sensors into the device, such as measuring the pH of the soil or the speed of wind. Lastly, while it doesn't require hooking up to a computer, it still requires a Wi-Fi connection, which means right now it can only be realistically used in urban or semi-urban areas. In the future, I might make it able to use cellular data, or in places with no connection at all, store the data locally on an SD card so it can be retrieved later. As for similar devices, I found a similar and local device from Frondly Plants that would measure the moisture of the soil and show you on a scale of 1 to 10 how moist it is. It also comes with a guide on which plants should be watered when. I sent the company an email with 3 questions on how the device works. As of now, I've gotten no response back. I also found a device by McBasil that measures temperature, humidity, and moisture, as well as pH and the amount of light. According to reviews, for some it works, and for some it doesn't. In the end, while my project didn't do all of what I envisioned, I still learned a lot about working with sensors, microcontrollers, web servers, and bugs. Hope you enjoyed the video!